Welcome to my channel. So today I'm going to be discussing about Eve, a framework for building agents from the Vercel team. So like Next.js for web apps, this framework kind of like replicates the same thing you have with Next.js using files, Markdown for instruction and skills, and TypeScript for tools. So I have a guide here that I will be sharing at the comment section for you to follow along with me. So if you look at what Eve is here on my guide, it said durable agents as ordinary files in a TypeScript project. So the pitch is Eve is Vercel framework for building durable AI agents as ordinary files in a TypeScript. So instead of a large configuration object, each part of your agent gets a clear home, instruction in one file, tools in one folder, channels in another. So I'm going to be showing you how this folder structure looks like. So this is how your typical agent looks like using this framework. So you have agent.ts here. So you have an agent folder, you have agent.ts, and then you have instructions. So your agent must always have these two files, agent.ts and instructions. Then you have your tools, then you have skills. So your skills, and then you have channels. Then you have connection sandbox. So this is the same concept you have in Next.js being transferred to agents. So you could see the four properties that define Eve: the file system first, durable by default, multi-channel. That means you could communicate with your agents via HTTP, web, chat, Slack, Discord, Teams, or even WhatsApp, and even the CLI. So it also connect with like other Vercel tools as well. For example, we are going to be using the AI gateway to kind of like connect to our models and more. So if you look at if you've ever built AI agents with like LangChain and LangGraph, this is not different, but this kind of like follows file system first convention. So it's built on top of the Vercel AI SDK, and similar to other agents as well, you'll be able to achieve the same thing as you will achieve in other agents. So let's look at the mental model. So if you've ever built app with Next.js, you know that you have this app router. So you put a page, for example, page.txt. This is kind of like the home page. And then you have a layout page, layout.ts, that is shared across all the pages if it's in the root. And then you have middleware.ts that runs on every request. So this is the same thing they are kind of trying to replicate for agents. The same pattern. Here, instead of having that kind of a situation, you have your agents, and then your agents have tools, have skills, agent have channels, and even agent can have sub-agents that have the agent.ts files. And then you can have schedules, which are kind of like things you run on schedules. So this is basically what it is. So for an agent to run, one of the things you need to take note of here is that the instruction.md will be in every turn. So every turn, your agent need to know, for example, that it's for example a real estate agent at each time. But for skills, for example, if it's working with PDF creation, if it's working with a skill maybe for front-end design, it will use those skills on demand. So very similar to what you have in other model as well. So as you can see, we are going to be scaffolding a project, and then we're going to be seeing exactly how this works. I'm going to be sharing this HTML docs for you. If you want to you prefer going through this one, you could also do that. So let's go to, so the prerequisite here is that you must have Node.js 24 or newer. So if you don't have Node 24, you can use a tool called NVM. So it's kind of Node version manager. So it enables you to kind of like install multiple versions of Node.js in your system. So if you want me to show you how that looks like, so I could come here and show you how to do. So they call it NVM. So Node version manager. So if I put NVM here, so you're going to see here, it's taking me directly to a place where you could see how to install it. So you see here, so this is the NVM. So you could find documents very easy on how to go about installing your agent. So the next thing you need to do to set up an agent, which is super fast, is you just need to do npx if latest init. So I'm just going to take this command now, and then when we are going to switch to our IDE. So within here, I'm just going to create a new folder here for our agent. So I'm going to call this one if 101. And then within this folder for this agent, I'm just going to open it in the integrated terminal. So I'm kind of using Devin for development. So Devin is, so it was formerly Windsoft, but recently it just changed to Devin. So you could update it to Devin. So here I'm just going to paste this. So what this does is it just initializes the whole agent project inside of this folder. So let's see how this happens. So you see it's asking, I will give it and go ahead to proceed, and then it's going to scaffold the project here. So you're going to watch here and see what happens. So now just look at what happens. It discovers that I'm running the Node.js version 22.22.3. So what I'm going to do is that, because I have nvm installed, so if I do nvm and if I do use, and then I decide to say, for example, LTS, let's see what happens. So it said no LTS version. So let me see what happens. So let me do nvm ls. So this will enable me to see all the versions that I have installed on my system. So you see, I have a version here called 26.4.0. So let me try to tell it to use this version. So if you have nvm on your system, so I will say nvm use, and then I'm going to paste that version. So this will enable it to use that version. So now using version 26.4.0. So now I'm going to go back to the command to initialize my agent. So you see now it works. You see it created this folder called my agent inside of this if 101. So I'm just going to give it some time to install all the dependencies. So one of the dependencies is installing here is if itself. Then it will also install. So if you switch back, you see that it also installed if AI and Zod. So Zod is kind of like this validation library in TypeScript. So that's what we're going to be using. So now look at what we have now. So we're going to switch back to the code. So when we go back to code now, you discover something interesting. So what you see out of the box here is that we have the entire if project here. So this is the entire if project. So what I'm going to do, I might just go to the, so open this project. So I'm just going to say, for example, so let's see what happens, whether this CLI is still active. So maybe we use Devin, and then we do. So Devin doesn't have a CLI. This is crazy. So whatever happens, so let's just see how it works from here. So here you see that we have our agent folder. And what you could find out here is that we have this agent.ts folder. So we have a model here. And we have a model here from Anthropic. That is the default model that is being used here. You have an instruction.md file. You are a helpful assistant. So this is where you actually tell your agent what it needs to do, what it will do, and the rest. So, and then you have a channels. By default, we just have this if channel. So this is just for interactive local development. Less the if TUI and your Vercel reach the deployed agent. So this is for local development. So we could create other agents in the future, like to connect to Slack, to connect to Telegram, and more. So for now, let's just go ahead and start our agent. So because when we start our agent, we'll be able to configure this AI API gateway. So I'm going to show you how this AI API gateway works by default. So let's see, let's start our project in dev mode. So I'm going to go back to the terminal here. As you can see, if we come here, so we'll get this start if dev. So that's what I'm going to choose. So I'm just going to say start. And now by default, you see it said building and compiling our agent. So the first thing you notice here is, look at what you notice. It's asking me some basic configuration for my project. So if you see here, it's asking me for my API Gateway VI project. It's also AI Gateway VI project. So authenticate with AI Gateway automatically in a new or existing, no keys to manage. So this one is there. So the other one is we need to go to the AI Gateway via this key. So I already have this key. So I could show you how I got the key. So if you come online, so you're going to see, so if you come to a Vercel project, somewhere here within your Vercel project, you're going to see this AI gateway. So if you open the AI gateway, so one of the things you find out of the box is, so you see here, I have $5 free credit. So if you don't see this, it means you need to connect your card to it and to be able to access that. So with this, so if I click here, so you see here, it's telling me in case I want to add more payment, which I don't want to do for now. So you could see here, there's something here called model list. So this is where you see all the models that are available for you to use via this gateway. The next thing you see is the API key. So immediately you sign up, you'll be given an API key. So this is where you create the key. So if you create this key, this is the key we are talking about here. So when we go back to the code editor, so this is the key that we are actually being told to bring here. So I already have the key. So that's how you create the key via Vercel, and then you generate this key. So if you create this key, what it does is to create a .env.local file with that key in it. So what I'm going to do is that, so within this project, I have this, look at it here. So I'm just going to copy the key here. And what I'm going to do is I'm just going to paste it here. So just going to say paste. So let's see. So we go for the second one, sorry. And I'm going to say paste. So now we have the key. So it's validating the key. Now you see the key is being created. So if we go back to the project, which is this if 101, so somehow you see we have the same, the file .env.local was being created. So now the next thing we need to do is actually to set a model. So what we can do now is to do /model. So I just need to come back here to select the model. I just do /model. And then within this model, I'm going to tell it to change the model. So I'm going to use a very cheap model. Since it's just for development, I'm going to use something like GPT-4. So I'm going to go all the way like GPT-4.1 mini or nano. So this will be very, very cheap models. So I will use mini. So I'm going to press enter. Automatically in the project, if you discover, what happens is that the default model in the agent.ts also changes automatically. So the framework changes this model automatically. So you see, so now we've been able to change our model. So now you can start right away to chat with your model. So let's try to ask it, what can you do? So we can say, oh, sorry. So directly here, we can ask it, what can you do? And you see it's working. So you see I can assist with a wide range of answering questions, assisting with coding. So you see it's working. So the model is actually being connected via the gateway, and we have an agent. But this agent is not configured properly because we've not updated the instruction.md file. We've not upgraded the agent.ts file. So let's go back to my notes. So we go back to my notes. So this is what we did. So we set the model credentials. So this is what you will do if you have an existing project and you want to add if to it. So this is what you do. So this is how you could also manually install. So you see the two most important files in your agent is this instruction.md and agent.ts. And this is how you have your agent. So you see we're already chatting interactively with our agent. So the next thing we're going to do is how to add a tool. So this is what we're going to do. So we're going to add a tool to our agent. So we will be following almost a very similar example with the ones we saw on the docs by adding a similar tool called the weather tool. So you see what we built so far is we've initialized an agent, but what we've not done is we have not created a tool. So now I'm going to update this identity. You are an expert weather assistant. You can fetch weather for any city. Always use the weather tool before answering questions about conditions. So you see, so this one, we're going to take this one now. I'm going to copy it and I'm going to use it here to update our instruction.md. So within here, I'm going to update this instruction.md with that information. The next thing we're going to do is we're going to add the tool. So the way you add tools to your agent is that within this agent folder, so what we're going to do is within our agent folder, so you see where we have agent here, we're going to look for the tools folder. So here we don't have a tools folder yet. So let me minimize this. So you see there's no tool folder now. So what we need to do is right on this agent directory, we need to create a new folder called tools. So you see, this is what we need to do. So within this tools folder, what we need to do is we need to define the tool. So the tool in this case, we'll use a file, we'll call it get underscore weather. So So we get weather, then .ts. So this is our tool. So automatically this becomes a tool. So then we are going to import both zot. So we're going to be defining the function. So for the sake of time, I'm just going to take the function because it's already written in the docs. So if we switch to the docs, see, this is the function. So basically what we are doing here is that we are importing define tool from if/tools, and then we are importing zot for validation. So here we are using this export default define tool. So we are giving the description for the tool, and then we are defining the input schema for this tool. So it's an object that has city, and then we are specifying the object. So it's going to be city. So it's going to take just city. So city with a string, and it will be minimum of a single character. So you see, and then this is what we've been able to define as the schema for the input. So we've defined the description. The next thing is this async execute that takes this city. So what it actually does is that it fetches the city. So using this weather API URL. So if we have a real weather API URL, it's going to fetch the city from this weather API URL. Then we can run, and then we can send it a message like, what is the weather in Brooklyn? And then we expect to get an answer. So for now, we might not really use this example with an API. We will just mock this to see how it works. So I'm just going to take this function for now. So, and then I'm just going to paste it on the code side. So this is where I'm going to paste it. So this is our tool. So what I've gone ahead to do is just to vibe here that will tell you make it return for some selected cities hand-coded, not API call. So I'm replacing this API call with a set of hard-coded cities. So you see, so now I can accept. So now when it takes in the city, so for some particular states or from particular city will supply that will be in this list of cities, it will give us it will respond back by telling us, for example, that this is the weather condition in that city. So this is what we want to do. So this is how you use tools. So the basic thing here too, the reason why I didn't actually use an actual API call, I don't have an API to call, but in a real production scenario, you might likely have an API that you need to call. And then you just need to put it in these tools, call the API and get your tool, talk to the API, return the actual weather for that city. And this is what you do in a real scenario. So now we will go ahead. We don't need to change anything on our model. We don't need to do. So this is what this file stuffs really helps us. So what we can do now is to run it on TUI mode. So we have a choice. So we can either hit it via HTTP, or we can run it on TUI mode. So like we've always been doing. So let's try this out and see. So what we're going to be doing is that let's go back to our code mode. So I'm going to use Command C. So Control C to cancel. And then I'm going to run the agent again by using npm run def, because we also have like a package of JSON you could see for if def. So that we can test it out. Oh, sorry. So we have some logs here. There's a problem. It said there's a missing script called def. So let's see. So we need to do cd into my agent. I think that's where the problem is. And then we can run npm run def here. So here it will work. So the reason why that happened was that I created a folder called if101 before I created my agent. So now I can chat with my agent. So we can just go back to our weather tool, and here we'll be asking for so the weather in Sydney. So let's see what happens. So if we ask our agent the weather. So let's just tell it like, tell me about the weather in, so we're just gonna say Sydney, and let's see what happens. So you could see here, so the weather is currently clear with a temperature of 77. So let's see what we have for Sydney. You see clear with a temperature of 77. So you see that the tool call was actually being made using this tool. So we didn't need to, like in most framework, you have to kind of like wire in the tools here. Automatically, Eve is able to know that in this folder, tools are being defined and the tools are going to be called automatically. So let's switch back to the docs here. So you could see here that we've successfully built our first agent. So we've successfully built our first agent. We've added the tool for weather, and then we've also been able to run it. So, but when we did that, what actually happened was that we didn't actually try using the REST API. So, or maybe streaming the section. We didn't do all this. So what we did was using the dev TUI. So the dev TUI. So you have options to be able to use to communicate with your agents. One of it is the interactive terminal UI, which we used. And you could see that we were able to chat with the agent to ask it about the weather, and it was able to tell us about the weather. So you could also use the HTTP API. So that is how you get to talk to your agent. So for now, I think the TUI is okay. So subsequently, we will see how to use the HTTP API to communicate with your agent. So the next thing we're going to be doing now is talking about the core concepts. So these core concepts are actually very necessary in order to understand how to build agents with Eve. One of it is the project layout. So for the project layout, every slot under agent and what lives where. So we need to understand. So as you could see here, so the instruction.md always on system prompt. So this should be minimal as possible. You could also use .ts. So if you're using .ts, then you're going to be using the instruction API. So we will get into this later. There is a complete section down here on instructions. So it will be always on and is recommended. So then you have your agent.ts. Here is where you do things like compaction, your output schema. Here's where you actually define the runtime configuration of your model. So you have tools, which are just TypeScript functions. You have skills, which are on-demand procedure that are loaded into your model. You have channels, which are ways in which you communicate with you have connections, which basically you're connecting to an MCP server, or you're creating a local MTG server to share tools with your models. This way you do it. We have sandboxes. Sandboxes are environments where you run command. So you have sub-agents. Sub-agents could also have exactly the same definitions you see earlier. You have hooks, you have library, shared codes, and then you have instrumentation.ts, which is like telemetry and debugging setup. So all these things is what you get. But for a very minimal agent, this will be okay. The instruction.md and the agent.ts. So this will provide a working agent. So you see some naming convention here. So we use snake case to name our agent, for example, to name our tools. And then we use kebab case or directories for our skills. For sub-agents, almost the same thing like the agent itself. So for schedules, you see, this is how we name schedules. Under schedules, you put billing and then you provide the TypeScript file accordingly. Another thing you need to understand is section, runs, and streaming. So I'm going to go through this. So section, runs, and streaming. So whenever you when you start chatting or when you start communicating with your agent, let's say using the TUI, for example, when you start doing that, what you're doing is that you started a new section. And each time, one execution cycle of your section. So when one section completes from the beginning, from message arrival to completion, that's a run. So with stream is different. It's an ND.json event feed from a run. So a stream is basically a series of these messages that are stored in this ND.json. So look at the life cycle of a section. So when the message arrives, run starts. So section has started. Model thing, call tools, maybe needs input, need approval, done or packed. So section completed. You see what a section is. So what durability means is that it survives restarts, it packed indefinitely. For example, if you have a tool call in between, it's going to pack, and every step is checkpointed. So that's why it's durable, because as every point is checkpointed, let's say, for example, you start, you call your model thing, you call a tool and things fail, you could still come back and continue. And this also should influence how, for example, you define your tools. Your tools should be implemented in such a way. So your tools should be implemented in such a way to support idempotency. That means when they run, it shouldn't redo what it has already done. So these are scenarios where your agent could actually pack. So when it's requesting for input authorizations or section is completed. So this is how your agent packs. So this is how your stream looks like. So clients are attached to a run stream via. So this is how you hit it with a get request, and the stream is an end JSON, one JSON object per line. So you see how it looks like. So this is exactly how it looks like. So the next thing we're going to be looking at is the message. So this is actually very important. So for a message, what happens when a message arrives end to end? So we're just going to be talking about this one. So the first step is channel normalization. So each channel, let's say HTTP, Slack, or where has its own input shape. The channel job is to turn platform input into if messages. So this is the first thing that happens. The next thing is context loading. So if assemble what the model will see. So it takes your instruction, your history, your visible tools, and loaded skills. So these are what actually builds your context. So remember, you normalize the channel to get the same message for every channel. So every channel at the end will have an if message, and this if message will be passed to the next step, which is context loading, for you to load the instructions and whatever things that then the model call. So if calls the model with the assemble context. So with this context generated, if is able to use it to call the model. And so a text response, they reply, a tool call request, for example, with this, a request for input approval, a sub agent delegation. So these are all what is part of what is used for the model call. So an execution branch, which is step 4. Depending on what the model return, if return the appropriate branch and loop back to step 3. So it continues. And then each step, every tool call, model response, and state change, if persist them to the durable store. So if as this thing called world, so you could bring your own, or you could use your local world, which is kind of like your local execution environment. So streaming and also channel normalization outbound. So this is exactly the flow. So I'm going to be sharing this material in the description section. So if you want to like dive deep into if and look at it properly and read this more properly for it to sync, maybe that will be helpful for you. So let's look at the default harness. So by default, if comes with so many inbuilt tools. So I'm going to be going through the tools. So the default harness here is the loop and the built-in tools every agent starts with. So what if ships with by default is the bash tool, the read file, write file, glob, grep, and agent. So agent is what delegate to a copy of agent building. So this agent also can also create copies of the agent itself. So the load skill is what enables Eve to be able to choose the appropriate skill to load in your context. So I think this is very important to know. So the load skill, because this tool is how if is able to talk to other agents or create copies of the agent itself. So this is how you can do something like parallel processing. And then this is how you could load a specific skill. So compaction here has to do with, so when your message gets big, if has to kind of like do compaction. By default, it is 90%. But let's say you want to compact sooner to save token. This might also have an impact on the performance of your agent. So you should choose a number that actually you feel is safe. This will actually help you save tokens, because by compacting, it means that your message length will become small and the number of your input tokens will actually go down. So, and this is also something you should know. So when you look at the fact that we create tools in a particular folder called agents/tools. So this is where we create our tools. So there is a particular tool. So if you want to replace a particular inbuilt tools, like the tools you saw earlier, it's just left for you to create a tool with the same name. And then if it's going to replace the functionality of that tool. So, and you could use that approach also to disable built-in tools. Next, we are going to be talking about durability and workflows. And workflows. So the workflows SDK under the hood was and checkpoint. So these are what we're going to be looking at. So what durability really means here is that it's crash safe and long running. So for your workflow SDK that is running under the hood, when a message arrives all of these steps are being checkpointed. So to make sure that if there is a crash, let's say in step 3, you don't need to start all over again. So the whole stuff starts back at the fail step and completes the cycle completely. So this is what happens behind the scene using the workflow SDK. So what normally happens is that you have a wall. So the wall here is basically how you save this checkpoint. So you could see here for some self-hosting scenario, you might decide to use this wall Postgres. That means the entire checkpointing will be done on this Postgres. So what it means is that when you're defining tools, you need to define them using these idempotency patterns. For example, here for things like payments and send, if a payment is already made, you want the agent to return already processed. So you need to define your tools in such a way that when they run repeatedly, they don't actually be harmful to your system, but they kind of like just still works. So what you don't write is the checkpointing, the state serial, resuming, handling, and crash recovery. So all those things are made possible within Eve because of the fact that behind the scene, Eve works with the workflow SDK. So most of these stuffs have already been handled in the first example we did. So for model and providers, so it works very well using the AI gateway. So the AI gateway is kind of like what Vercel gives you to kind of like provide you with like API key, routing between models, different models of your choice. You could even bring your own API key and Vercel will help you route it. So via that gateway, all you need to do is define this API key. So if you can look at it in the code here, you could see here that we have this env.local. So we have the AI gateway API. It actually had to set it by itself when I did npm run dev. So it asked me what I want to use to connect. So if I also had a default provider as well, as you see here, whether it's Anthropic, so you could easily install the provider, and then you bypass the gateway by just providing the model like this. So you could also do that. So it's actually very straightforward. So choosing a model. So you see, so this one helps you long context, multimodal. These are some of the things you consider: cheapest, fast, simple tool use, depending on what you want to use. So in most cases, you don't really need like very advanced model. And this is how you could set up a model in your local environment and use a model, some other model in production. So you could see here, you have two env files setting two different models that you're going to use depending on the scenario. So your model also has options as well. So this is where you set the options for your model. So, and be mindful to track your costs as well. So because you should be responsible in selecting your model that actually makes sense. So now we're going to be looking at instructions. So instructions are your agent's way of. So instruction files actually help your agent to actually do a specific thing. So this is where you give like you are an weather assistant, you are a research assistant. You tell the agent what it will be doing. So this is where you give it the instruction. Instructions are agent always on system prompt, the permanent identifier rather than a procedure it pulls in when the moment calls for it, like skills. Use them for anything that should hold on every turn. So a persona, a constraint, if prepends the instruction to every model call in the section. So you need to actually know how to write this. So if you write a very long instruction, just instead of conveying something small, then you know definitely that it's gonna cost you a lot. So what's the difference between instructions and skills? So instructions are loaded on every turn, permanent identity tone, standing rules, while your skills on demand when the model call load skill. So the load skill tool will decide what skill is relevant for your conversation, the conversation currently going on within the run. It will decide and provide your agent with the appropriate skill it needs. So you could see 3 ways to author Markdown, TypeScript, split directories. So You see, under the agent.md UI concise assistant, use tools when they are available. You see, this is very straightforward. So markdown instructions. So we are actually going to be looking at markdown instruction, TypeScript instruction, splitting instruction, and how to write these good instructions. So in the simplest form, you see, UI concise assistant, use tools. So what goes in? So here you can say you are an expert weather assistant for the continental US. Tune, be concise. Standing, always call the weather tool. So you see identity, tune, and standing rules. So all these are what you put in your instruction.md file. So you see, you can format them nicely. So markdown formatting. So it's typically they are kind of giving you some length guidance here. So between 1 to 2 lines for simple assistance, 10 to 30 lines, 50 to complex personnel with many constraints. Two probably should be split into skills. So when it gets too big, you need to split them into skills. So for TypeScript, so you see here, you are kind of like using this API. So you have instruction. So you define the instruction from if/instruction, build instruction prompt. So prompt.js, and then you build instruction prompt here. So let's see an example. So here you can even compose from multiple files. So this is how you could also split your instructions into multiple files. So you could say, for example, the identity, the tone, the constraints, and the tool guidance. So you have all of this inside of the instruction folder. So if you prefer this approach, you could also do it. So you could also use pick and choose what you want to do. So you see, this is dynamic instruction. So at some point, they are also returning markdown as well. So you could read about this. So let's look at what makes a good instructions. So there are 5 section patterns that makes a very good instructions. One is identity, tone, standing rule, tools, and escalation. So the 5 section pattern. So identity, who the agent is, the rule, the expertise, and the personnel. Tone. So you could just remember it by saying it's ITS, it's TE. So identity, tone, standing rules, tools, and escalation. So for example, you are a helpful artist and this is weak. You are an expert, this is better. Tone, be friendly and helpful. Weak, better, lead with the answer. And detail only when asked. Standing rules. Always check the user's subscription status before putting prices. So you see, tool guidance uses. Use this tool for this and this for this. So you see, so this is actually very useful because you should know how to write good instructions. This actually will impact the performance of your agents. So now we are back to tools. So this framework is actually easy to use. I think by just basically looking at how Vercel structured this into using of the file system. So it means you don't really need to do the wiring. So you don't need to wire your tools to your agents. All you need within an agent, you just need to put the tool in a folder and automatically that folder start doing the job. So what a tool is a TypeScript function that the model can call. So that's what it is. It has a description, input schema, wizard, and an async execute function. So that's what makes a tool. So you've seen example of this tool that we wrote. So if I check back to our project, you could see the example of this tool. So the get weather tool that we authored together. So you could see it here. So this is a tool. So it has a description. You see here, it has an input schema, which is validated with Zod. And it has an async execute function. This is actually the function that takes whatever argument that is to be passed to the execute function, particularly the input schema. And then what does it do? It calls whatever processes need to call, whatever logic that need to perform, and it returns back something. See? Which is actually what will be returned from the tool call. So if you see here, you see this is a minimal tool The three things that the description, the input schema is here, and then of course you have the execute function. So very simple. Naming rules, we've talked about this area. So what this section is going to actually cover is we're going to be looking at the define tool API, the tool context, approval, and HITL, gates that pack the section, building tools, tool errors, structured output, and code mode. So we're going to be looking at the tool API. So this is how you defined a tool using if. So all you need to do is import the defined tool from if/tools and then use Zot for kind of like validation. So you could see here, you export default defined tool. And just like we did in the last example, so if I switch to code mode, you could see the same thing happened here in this tool. So we just imported the defined tool from if/tools, and then we provided the description for the tool, we provided the input schema, and we defined this async execute function here that actually does the execution of the tool. So when a tool is being called, it uses the description, the input schema. So there are other things that were excluded here, which is optional. For example, if you go back to the code, you could see that we could also have an output schema defined here. So your description, so you need a very nice description. So if you say, for example, user lookup, this doesn't make sense. You have to use a sentence for your description because this description will be wrapped into your instructions, and this will be helpful in your agent to actually make the tool call. So this is weak and this is better. So look up a customer by email and return their account ID, subscription tab, and current MMR. Use this before answering the account or billing question. You see, this is exclusively covering when the tool should be used. So this is how you define an input schema using Zot. So of course, if you are not familiar with Zot, you could check that out. So these are the primitives that you have with Zot: string, number, boolean, and date. And then for validation, you have like min, max, email, URL, and regex. So you could see here that the dot comments also matter. So for example, you could use the dot describe method to fill description for each of the field. For example, city, the city name example. See, this also matter. This will also be wrapped in. So the execute function, it takes the tool context as an argument. So within this tool context, you could do a host lot of other things. So we're going to be discussing it somewhere next. So the execute function, for example, you see here, you're actually doing a DB call. And because of the way if works, the idempotency of the calls you make. So for example, if you make a call to a database and something fails, when you come back to it, to that step that fails, if we checkpoint everything, it's going to store everything in your database or whatever you're going to be using as your world. Remember when we talked about the world? So that if has a world, and that world enables it to remember. So in this case, you need to write this function whenever it returns or it executes something that has already been stored on the DB. You want to make sure that it's safe when you run it again. So you see, you return any JSON serializable data. So, and these are kind of what your return values should be. Focus only on what the model need to answer. Object with name field small. Don't dump this kind of large amount of data. So the output schema is also optional. So you could decide to put it or you could decide to leave it. So one of the things you also see here is approval. So you might decide to say, for example, if your tool is going to be deleting files, that kind of a tool, you should put approval so that the user is able to see whether it's a decision it needs to take or not. So we're going to be looking at tool context next. So we talked about the fact that when you are running this execute function, so if you look at the code, for example, well, in this case, I didn't provide CTS as a second argument. So CTS definitely come after this object. So here, so this is where you provide the CTX. So you provide CTX here. And then you could use CTX to do a lot of things. So you could use it to get authentication. You could use it to check connections, state, hooks, channels, section ID, request ID, and a lot. So you could see, so this tool context is really, really important because it enables you to kind of like get access to the outside environment of your agent. So you could see, you could get sandbox, a light sandbox handler for running commands. You see, you could authenticate your principal user. You could do you could authenticate service clients. For example, you see Stripe and the rest. You could look at your state, you could modify, you could store, you could do hooks, lifecycle hooks, like before a particular step, you could which channel the message came from. So ctx.channel. So all this information can be achieved. So if you see here, for example, we in this tool, let's look at this tool, for example. Here we're actually getting the sandbox. So this is our ctx.get sandbox. So we are using the ctx to actually get the sandbox. And after we get the sandbox, look at what we are doing. We are actually writing the file. So you see, so we are getting the sandbox and then we are writing the text file. So you see, and then we are doing sandbox.run. So we are actually, with the CTS, we are able to have access to the sandbox that is configured for us. And then we are able to make this, run this Python script on our sandbox. So here you see we are attending, we are kind of doing user authentication here. So, and here you're seeing how we are getting access to connection. Here we are doing state. Just like I said earlier, I'm going to kind of like share this note with you on the description section. I'm going to put it on a drive and share it with you so that you can download. So if you want to like use it as a reference material when writing your agents with Eve, so you could see the execute. So this is what the CTS is now. It's not global. Each execute get a fresh CTS scope to the current node, not for cross-section state. Use your own database for that, not for secrets. So you don't use CTS for those kind of stuff. So the next thing we're going to be looking is approval. So we're going to be looking at our approval. So we are going to be looking at approvals. So this is actually very important. So some tools have side effects. For example, they will want to delete your file. They want to make some stacks that you really need to monitor. So what happens is that because of the durable nature of Eve, it's going to pack until it's resolved. Why approval matters. So some tools have side effects, just like I've said, and you don't want the model to trigger them autonomously. So because of that, you need this approval. And the way you do that is just by putting them in your tool. So you just put approval required equals to true. Sometimes you might also define conditional approval. So some approval might happen based on some conditions. So what happens when the model calls, you see, model emits a tool call to issue refund if sees approval is required. So if emits authorization, so to you, and then you need it packs because it's durable. Why not? Until you approve, then it can continue the section. So that is what happens in this approval. So the authorization events is authorization required and authorization complete. So tool needs approval and then approval resolved. So these are the two states that you have. So conditional approval, just like I told you earlier, approval could be conditional. So for example, it's required for a certain situation. So not for all situations. So when the input amount is greater than or equal to 10, so that is when it is required. So for lesser amount, there will be no need for approval. So approval could also time out. So what the model sees on when approval is denied, if tells the model the call was rejected, a well-instructed model then explain to the user, I couldn't process that refund without approval, rather than retrying indefinitely. So this is what happens. So we're going to be looking at built-in tools. So in the earlier, so when we started looking at tools, I told you that there are tools that are packed inside of Eve. So Eve come with these tools. Most agent frameworks, such as Gwenpa, which is kind of like my favorite, or come with such tools. So you have batch, read file, write file, glob, grep. So these are all the tools. And these tools could be replaced. So if you define a tool and put it in this folder. So I'm going to show you on the code folder here. So when you define a tool with the same name and put it in this folder, it automatically has precedence over the built-in tools. So if that's your concern and you want to kind of like override the tools. So you could see the bash tools, how they work. So you could see run a bash command in the sandbox with /workspace. So you see, so read and write file. So direct file under the /workspace. So you see glob. So the workspace is where your agent is actually working from. So load skill, the skill loader. So this one is actually very useful because you have a lot of markdown files about your skills, and then your agent is going to choose the right skill that is going to load into your instruction set for your particular run. So you see what I was telling you earlier, overriding tool call. So you define an author tool at the matching file name takes priority. So you need to take note of this. You don't create tools that have the same name like the built-in tools. If not, they will be overwritten. So that's why you need to take note of that. So we're going to be looking at next is tool errors. So returning errors versus throwing, how the model reacts. So there are two ways to fail is return an error result. The model sees it and decide what to do. So throw an exception, the model get a generic error. The turn may fail. For most cases, return error as data. It gives the model more information to recover. So I think this is the best because you're working with an agentic system where everything is like message exchange. So if you throw an exception, it might break stuffs, which might might make the agent to be kind of confused. But when you return errors that are good, for example, you could see when a customer is not found, you return something like this. This is the recommended approach on how to get things done. So this is about errors. Other stuffs are also available here. I'll be sharing them with you if you want to like dive deep into understanding if very, very well. So structural output. I told you the same. I showed you this the other time that when you are defining outputs, so you could define your output schema. So you see here we have an output schema. So what this output schema does is that it checks to make sure that the output of our model aligns with the output of that the output of our model aligns with the output that will be validated using Zod. So this is what you get out of the box by using Zod. So I'm not going to say much about it because I've discussed it earlier. So let's look at the code mode. So what is the code mode? It's an experimental feature where the model writes JavaScript that call tools inside the sandbox. Rather than calling tools at a time through the standard tool, it is an opt-in flag that can change or disappear in any release. So code mode is experimental, so it's something you might decide. So this is the difference between the code mode and the standard tool call. So this one, it admits structured tool call, framework runs each. This one writes JS that call tool functions, runs in sandbox. So this one is an experimental mode. So it might, so you just set it here, experimental code mode equals to true. And when that happens, look at what multi-step data product, redefine, transform, write, back, compare, iterative refinement, loop until a condition is met. So code mode gives you much power, but at the same time, it's experimental. We don't know whether it's going to be removed on new versions of Eve, because Eve itself is in beta, and I think I don't really advise you to use Eve itself in production scenario for now, but it's actually a good framework that changes the philosophy on how to write models, how to write agents. So skill overview. So what is a skill? So we talked about, if you look at our code, look at what we talked about. So when you see an agent, so this is an agent, the whole of this folder where we have if 101 my agent. So my agent is a folder, and within the folder you have this agent directory. So this agent directory, if you look at it here, we have channels, we have tools, and we also need another folder here called skills. Skills. And these skills, it means we could define multiple folders inside of it. We could also decide to just write the skill here, or we could define, let's say, for example, I want a skill for research. So we could define the research skill here. And then within this research, we need to create a file inside of research called a skill .md file. .md file. So this is where we are going to write like instructions. So a skill enables you to have a minimum instruction.ts or instruction.md file. So when you're writing this file, let's go to instruction.md. So you are an expert weather assistant. So when this file becomes too long, you need to break it down into skills. So let's switch back to my docs. So you see here what a skill is. It's a loadable procedure that follows the skill.md convention. So you see there, it's a markdown document, optionally a package directory with supporting file, and that the model pull into context on demand. So the key thing to know here is that skills are being pulled into on demand. And then we have a special tool that does that, which is the load skill tool, which helps us. So you see here, progressive disclosure. The the same model as code splitting in web app. Don't ship every procedure in the system prompt. Ship short description. Let the model pull full procedure when relevant. So you see here, help me draft a release note. If shows the model description of all skill, research, release, model calls load skill. You see? And then if appends the skill full markdown to context. So this is what happens even with most of the frameworks you've been using. So your skills, you might have so many skills, but only skills relevant to the context are being pulled in. So this is much you should know about skills. So this is, you see here, they talk about the instruction.md. That's why I said this has to be minimal, because this is loaded into every run, while the skill.md is on demand, while the tools are always visible and they are executable actions that your agent need to take. So you see here, what we will cover in this section basically is to look at markdown skills, package skills, define skill API, and how loading works, and agent skill standard. So I'm going to go through this briefly for you to actually understand what skill is. This will help you to even understand other agents as well. So look at what I was just telling you. So you have an agent, you have the skill directory, then you have focus.md. So in this case, you see the smallest skill, use the weather tool before answering focus or temperature question. So this becomes a skill. So you see, and this is it. So that's why I told you, if you go back to code mode, there were two options. Another one is here, you see we created research and created the skill.md. So let me rename this. So let's see, rename. So we're going to change this one to lowercase. So skill.md, or we just create within the skill. For example, in this case, we can create like focused .md. So focused all lowercase .md. So, and here we could pull in and tell it to write exactly like we saw in the docs. So you see, use the weather tool before answering focus or temperature questions. So you see, we've defined this skill. So it depends on what you want. You could decide to use this, this or this technique. So let's go to the next one. So markdown skill. So you see here. So you said the flat markdown file in. So you have a flat markdown file in agent.skills. The content is the procedure. The name comes from the path. So you see. So skill, this is what we did. Description inference of your skill. So the flat matter can skip the description front matter when it does, if advertises the first non-empty, non-blank first line. So you see, release checklist what becomes the description. So this becomes the description. So explicit description. So you see, description, this is what is recommended. So if you are writing a skill, you need to make sure that you have this description here. And I will just say, ignore this. If you do this and just paste some file, it's just going to take the top part of the file. But do this explicitly. See? So this is what is recommended. What goes in a skill body? So this is a step-by-step procedure, decision trees, domain knowledge, reference materials, and formatting and output convention. So skills generally help your model in kind of like doing things repeatedly. So if you have something like a video editing procedure that you want your agent to be doing and you want it to use a skill, it means that each time your agent is going to keep doing the thing based on that skill, because when the skill is loaded, it's going to give it a kind of like decision or step-by-step procedure on how that thing is done. So here is a learn guidance. You should be aware that these things are all loaded to context and it will be charged based on your input context. That is why you see that when we are initializing the agent itself here. So when we are initializing the agent here, so in the agent.ts file here, we have other options. So if you see here, we have something called compaction. So we have compaction here that we could define. So if I go here and dive deep here into this agent definition, so let's see. So it extends this agent definition. So what is in this agent definition? Let's see. So this is a type called public agent definition. So let's see what's here in this public agent definition. So you see, we have a description, we have build. Let's begin to see some other features we have here. we have context window, we have reasoning, we have output schema. So I'm actually looking for the compaction. So let's see this. So there are a lot of definitions here. Okay, look at what I'm looking for. So this interface called public agent compaction definition. So what this happens is that it provides a threshold by which is like more like a number by which um, your message could be compacted. So just defining writing a kind of like a skill that has so many lines just to describe something means you'll be spending a whole lot of tokens when it's going to be added to your runs. So take note of that. So you see, that's why you need to write very good descriptions that takes both descriptions and the step-by-step guides. The body of your skill should be in a way that actually saves tokens, but still allows your model to be able to do what it's supposed to do. So package skills. So package skill is a directory with a skill.md. So you see an example, the one I just created before. So here you have research, you have a skill.md, you have references, you have access, you have scripts. So you see, so this is what you call a package skill. It's a directory with a skill.md plus sibling file like references, access, and script. Use one when a single markdown file isn't enough. So you see, if you want to have like a very comprehensive skill that even need to have script, you need to package it. So you see here, we are even having a .py file as a script that your agent is going to use. So this is actually very important. So let's look at the define skill API. So you could also define same thing with the way we defined the agent itself, and we define tools. So if also has this define skill API. So the define skill API enables you to also compose almost something similar to how you compose both agents and the way you compose tools. So you have the description, you have the markdown. So the markdown is here, and then the files. So this, you see, so your entire skill, so you see research.txt, instead of defining the skill as a markdown file or a directory where you have markdown and maybe Python script, you can also choose if you want everything to be type checked and to be in TypeScript. So you could also define your script as a TypeScript file. So it depends on what you want. So how loading works. So I'm just going to show you this, the discovery plus loading flow. So at build time, if scans your agent skills and compiles each into a description. So runtime, every turn, model sees all skills description plus the load skill tool. Model decide whether to load a skill based on request. If yes, model call load skill. If appends the skill markdown to the active turn, model proceeds with the procedure loaded. So this is exactly what happens when you load a skill. So agent skill standard. So portable skills formats if work elsewhere and vice versa. So if skill format follow the broader agent skill standard that everyone uses, so it's not really different. The standard format is you have this. So it also follows this format. This is only what is required. Every other thing is optional. So that's all about this section. So in the next section, we're going to be talking about channel. So I told you I'm going to be providing you this doc if you want to really go deep into understanding if as much as possible. So we're going to talk about channels. So one agent code base, many surfaces, the channel contract. So what happens is a channel is a surface where the agent can get reach. So you could see multiple agents now. You can talk to them using their mobile apps. You could chat with them using a web chat interface, Slack, Discord, Telegram, or whatever. So within if they have this built-in HTTP channel. So every app she's with the HTTP channel. So if you look at it, there is a channel that is exposing this. We could check that and see. But we could add our own channels. So if exposes, so it comes with this CLI, which you could use to add channels. So we will be exploring this CLI for you to see not just the channel feature, but other things you could do using if. So let me switch to the code mode now. So here, what I'm going to do is that I'm going to do and so I'm going to just do. So let's see our node dash v to make sure that uh, so dash version. So let's see dash v. Let's see what happens. So we are running node. This if will not actually allow us to use this. So I'm using a tool called mvm. So I'm going to tell it to use version 26. So it's using version 26.4.0 with npm 11.17.0. So this one will allow me to kind of like use the if CLI or whatever you call it. So I'm going to use MPS. So I'm going to use if, then I'm going to do dash dash help for us to see all the goodies that it has. So let me take this one up here. So you could see here that let me take this one a little bit up here. Yes, I think now everything is showing. So you could see here that we have channels, manage user auto channels in the current project. So you can see deploy agent to Vercel production. So you can deploy agents. You see build the current if application. So start, you see dev, you see info, eval, help. So all these ones we could do them within the current context. So what I want to do is that I want to work with channels. So for channels, we're still going to go back and say if, and then now we're going to say channels. So this is how you discover the futures. So you do dash dash help, and then let's see what we have. So now you see you could add a channel, the same thing like what we had in the docs. So you see here we could say if channels add Slack, if channels add Discord. So now we could see add and then the kind. So let's go with add now. So we're also going to do if channel add. So this is how you progressively discover what can be added. So you see here add channels. So with dash F to false, yes, for confirmation require explicitly kind. So so the kind here you could see here we have Slack and web. So now what we're going to do is that we're going to add web. Let's add web as a channel and see what we get out of the box. So I'm going to be adding this web channel here. So let's see. So now I'm going to go with channel add. So I'm going to take the add, then I'm going to do web, and then I'm going to leave it like this. So look at what is happening now. So it's checking the current Vercel project. It's inspecting channel registration. It's scaffolding the web channel files. You see? So it's installing the channel dependencies. While this is happening, let's go back. So everything is being installed. So I will walk you through what was being created, how, and how the files are being created. So meanwhile, let's switch to this. So just to walk you back through what we just did. So what we did was we progressively discovered. We progressively discovered the futures of channels. So what we did here was we used the help to progressively discover what we need to do. So here you see we did. We found out that we were using. So we now did npx if dash dash help. So with this, we were able to get all the options that would like channels in it. After which we ran nps if channels add. We wanted to know the help for add, and then we saw that we can add channels like. So then we ran the nps if channel add web, and now it created. Now it's asking me which team. So it's going to ask me Sabi Edu project. So I'm just going to say yes. Link to existing project. So I'm going to say no. I'm not linking it to any existing project. Name is of this agent is going to say my agent. Do you want to change? So web Next.js service if has invalid framework. Do you want to change additional project settings? So I could say yes. Here, do you want default deployment protection settings? I will just say yes. So it's linked to that particular project. So there's a project. So it's deploying my agent now to Vercel. So my agent is going to have like a web interface. where I can communicate with my agent. So let's see. So it failed basically because our skill isn't in a format that is recommended. So if you open the skill folder, you see we added nothing here. So the forecast skill was okay. So I'm just going to take this folder out. So I'm going to move it to trash so that we have this forecast skill. So this one can even be renamed to have an E somewhere here. And this might be okay. So the reason is because I didn't write anything in the skill. It was just an empty file. So that would have likely been the cause. So let's do this and see what happens again. So now it's deploying. It gave me a kind of like some inspect URL here. So I can follow that and we could check it together. So, and we could see here that it's building. So it's building. This is the duration. This is the domain that is going to give me. This is for my agent. So, and one of the things you can't take away from Vercel is the fact that Vercel actually makes deploying and using solutions like this very easy. So if you kind of like working uh, for like a startup where you need to build agents fast, I think if will really be that framework where you move from writing agents to deploying them in production environment like super quick. So let's see what we get out of the box. So our deployment is complete. So we can see, we can preview our deployment. So everything is complete. So let's go back to our, so let's go back to the code mode. And then here you could see that we have some URLs here. So let me see this alias URL. So we'll follow it back and we open it. We open and look at our agent. So this is our agent. So you could see I could chat with the agent and say, so remember when you look at the tools we have for this agent, for this particular agent. So let's go back to tools and we see the get weather tools. So this means we could ask it for the weather of London. So what is the weather condition in London? So let's try London and see what happens. So we're going to switch here and then I'm going to ask it, what's the weather condition in London? So we're going to see what will happen if this agent was actually deployed. So I'm just going to, so we're going to say London and I'm going to press enter. So, so it's a production auth is not configured. Replace placeholder auth in agent or channel or if with your own app auth provider. So let's go fix this. I think this is something we skipped. So let's go fix it. So now when we come to code, you will see here that we already see what we could do. So here you see this placeholder will not allow browser requests in production. Replace it with your app's auth provider like Next.js or Clark, or use none for a public demo. So here, because it's a public demo for now, we're going to use none. So you see, so we're going to say none, and this is going to be it. So now we're going to be redeploying. So since we fixed none, so let's see. Oh, let's see. I think what happened is that we have not imported none, so we need to bring in none. So this is none and everything will be fine. So now we need to redeploy for our public demo for our agent. So we need to paste this and hit this. So now we're going to allow it to deploy again and then we're going to test it and see. So as you can see, The alias didn't change. I think it's exactly the same thing. So we just need to refresh. So now we try to communicate with the agent again. Now we know we have none. So there will be no authentication. So here I'm just going to say, what's the weather of London? So, and then we're going to hit this and see exactly what's happening. So now you see our get weather tool got called, and you see here that the weather in London is currently rainy at this. So this is what we're talking about. No other agent does it like this. So this is actually very beautiful. So you see, we've been able to deploy a production-based agent live on our interface using this. And this is the web channel. So the web channel has been set up for us and everything seems to be working very well. So let's see what we did again. So let's see. So what we did was we said nps if add channel web. So this was what we did. You see, add channel to if agent, checking no channels added. So skipping web chat scaffolding because it's already been added. So the first time it wasn't added, so it was added. So that's kind of like how you get things done here. So let's go back to, so we've added the web channel. So now you see, so the channel is a file under these channels. So, and the available channels, you have HTTP, which is actually built in, and then you have the web chat, which is a Next.js chat UI with use if agent, chat SDK. So this is what we've actually tried. You have Slack, Discord, Teams, WhatsApp, and a whole lot of other agents. So this is what we're going to be covering so quickly because I've actually shown you the practicals on how to get into the channel CLI via if channels add, then the name of the channel. And when you do that, you're going to add a specific channel. So let's look at the HTTP channel. So as we said, this channel comes embedded inside of if. So for example, you see, if you say if with this section, it starts a new section duration. Then when you grab the section, you can pass the section ID and subsequently send follow-up messages. So you could, I will be sharing this document. You could go to the full link of the HTTP API and you could see exactly how to work with it. So I think even the UI, the chat UI also uses it behind the scene. So this is the web chat. This is the one that we just did. So basically, we're able to add this. This is the fastest way to add. So this doesn't really take a lot of time. So this is what we just deployed. So it actually did this Vercel deploy for us. So you also have the Slack channel as well. So if you add that, so you do if channels add Slack, this is going to add the Slack channel for you. So let's look at the Slack channel. So the Slack channel also works almost the same way as the web. So you use the same API. So you do npx. In my case, I used to use npx if channels add Slack because if it's not installed globally. So I can just do npx if channels add Slack. And then when you add that, you need to connect using Vercel Connect. So you need to connect yours. So your credentials are not going to be managed inside of your agent. You don't need to throw credentials all around. So via Vercel Connect, that's where you're going to be able to connect. So there's also description here on how to set up your Slack channel as well. So I will be providing that description, the whole of this material for you in the comment section. So the other way is also Discord, very similar to the way you do for WhatsApp. So you see Teams, if channel add WhatsApp. So uses messages, user messages, your business number, the agent response, strong for customer support use cases. So the same thing with Google Chat, Google Chat bot integration, and the rest. So you also have like your auth and route protection. So you saw exactly what I did when I decided to authenticate. So you could also kind of like use your own authentication library. For example, this is HTTP channel, and then you could provide this authenticate method that take requests. You could do the same thing for Slack and the rest. So this one has to do with cross-channel hands-off. So receive handle work off between channel mid sections. So receive function. So for example, you could see here for defining a schedule, you could receive here, and so you take the receive, and then what do you do with it? So you take the channel, the user, and the message. So this one would generate the digest, then deliver it via Slack channel. So now we're going to be talking about connections. So connection bring external tools to your agent. So you're either going to be connecting things like MCP2, which is the model context protocol, or from authentication services such as GitHub, Stripe, or Linear. So depending on how you want to create your connections. So your connections generally will appear under agent/connections. And then when you check your available tools, you see this tool was authored, this tool was authored, but this is how it's going to show tools that are actually coming from connection. So there is a place here where we are going to be discussing how to create our custom connections. So we're going to be talking about So we're going to be talking about connection. So connection bring external tools into our agent. So whether they're NCP tool or via Vercel Connect. So all these are going to be possible using the connection feature. So your connection appears in your folder like this, agent/connections. And when you check available tools, you're going to see like this one was auto, these are tools, but these are tools that came from this connection. So let's look at MCP tools. So MCP tools can be connected. So you see here under connection, we have linear.ts, and this is how we import connect from the connect API from the Vercel connect/if, and then we define the MCP client connection from if, and then you can provide the URL and other stuffs that. So this is a connection being defined. So and this connection is going to expose a set of tools that your agent is going to use. So you see here there are different types of authentication. Here you are connecting via Vercel Connect. So you just provide the name of the connection, or you are connecting using some kind of bearer token, in this case like this. So, and then you could see your tools appear like this. So for local MCP servers, look at how you could connect. So very, very similar. So Vercel Connect is an integration layer for external services within Vercel. So it enables you to connect to services like GitHub, Stripe, Linear, Slack, and more. And then this is the pattern. So basically, just like you saw, you see here, the auth is connect GitHub. So it's going to be connecting using this connect is actually coming from Vercel Connect. So it's going to make this connection possible. And then here you're going to now, a set of tools will be exposed to your models that your model is going to use. So you could see here using connection in tools. So you see how, so create pull requests, you see execute title body, and then you see await github.pulls.create, so PR. So here is the connection being used here. So the connection is being used in the definition of this tool called create PR. And then you could see github equals to cts.connection.github. So you see here that the connection is being defined here. And then based on that connection, we are creating github now.pools.create. So many tools could be created using this same pattern. So here we're actually talking about connection authentication. So you've already seen it before. You via Vercel Connect. So where we just so how connection authenticate identity propagation. So here we have the channel auth, who is calling the agent. For example, this user mapping, the agent internal user, and then connection or credentials from external services. So these are the auth layers that we have. Either you have a channel authentication who is calling the agent, you have user mapping, the agent internal connection, and then you have the connection. So this is what happens when you in the identity propagation process. Each user agent uses the user connection. When a list agent calls GitHub, uses a list GitHub token. So you see, so you user connection is being used to connect to the agent itself, but when the agent itself calls GitHub, it uses the GitHub token to connect to GitHub. So within the context here, you see, so we can get access to this connection object using the context here. And here you could see how we are defining an MCP client connection. And based on this, we can get access to it using the context, and we'll be able to use it in our tools for execution. So writing custom connections. So this is how you write custom connection. So we're going to be seeing the approaches in which you could be able to write custom connections in Eve. So first of all, you can write a custom connection using Vercel Connect or your own available MCP servers. So the two approaches here is just to author a regular tool, or you wrap an MCP server if you're doing it by yourself. So most of the stuff you want to connect to are already covered with Vercel Connect. If it's not, and or by any other available MCP server, then definitely you want to use like your own regular tool that wraps everything, the call of the API, like you see here. So we have a defined tool, and then we have an execute method here that actually fetches from the API. We are able to store the internal API and internal API token as environmental variables, and we're able to call and return successfully. So you could wrap everything around a tool or wrap an MPTCP server. So you see here, we are actually creating a server.ts here as a separate project. And then look at what we are using. We are using the model context protocol, mcp.js. We are defining an MCP server. And then based on that MCP server, look at what we are doing. So the MCP server is being served via this URL. And that is how we create our own custom, both MCP server and then we're able to connect it to our agent to use. So I think the best approach here is it depends on what you want. So it's just to wrap everything in the tool is better. If it's yours, I think just using tools is better, because the essence of MCP server is actually to expose tools to your agent. So let's look at sandboxes. Sandbox overview. The sandbox is the agent isolated batch environment, a file system rooted as /workspace where it can run shell command, execute script, and read or write files without ever touching your app runtime. So every if agent has exactly one. So this is what happens. So this is your sandbox. So sandbox is for safety. So you have your badge, you can do all these things. So a working sandbox, you don't author anything to have a working override it only to add, set up, install packages, and sit file. Pick a backend, local versus Vercel sandbox. So local is when it's running on your system, and the Vercel backend is when you are using kind of like the Vercel, a Vercel, let's say VM behind the scene, or Vercel environment to run that. So this is what we'll be covering in this section. We'll be going to be seeing how to use the sandbox, the building tools day to day, the sandbox handle with context. We're going to be looking at the local versus Vercel sandboxes. We're going to be seeing how to set up the sandbox, network policy, and sandbox lifecycle. So this will enable you to properly understand how sandbox works. So your tool, the mental model here is as your tools runs in your sandbox. So tools runs in sandbox. So tool run here, badge file. So has a process.env within it, can call external services. So this is what a sandbox is. Just look at it more like an isolated, if you worked with Python, use an isolated virtual environment, kind of where your agent can run. So let's go to the next one, how to use sandboxes. So we have these tools. So using the sandbox. So just like we've talked about that the model already has sandbox access locally. So the only thing you're going to do differently. So these are the kind of things the agent does with the sandbox. So you don't really need to do anything. So let's look at the sandbox handle. So this is how you get hold of the sandbox. So you get hold of the sandbox using this context object in your tool, and then you get hold of the sandbox. And then this is how you could do sandbox.write text file. So you see, and then this is how you get the result of the run. So of that same file. So you can get hold of the sandbox using that. You don't really need to do much when it comes to using the sandbox. So sandbox backend. So just like we talked about, there are two backends basically. So you see here you have your local def, which is if you do if def, so local sandbox on our machine. When you do a Vercel deployment, you have a Vercel. This one is managed and isolated VMs. So self-hosted, if you do if start, this one is configurable. So local, this is for development, sandbox for production. So you could see here how define sandbox, and then your backend here is the Vercel sandbox backend. So runtime, you actually provide Node 24. So basically, more or less like you are creating a simple VM for your agent to use. So if you want to create a sandbox, it also the same way you create for agents. You have this agent slash sandbox, and then within the sandbox.ts, you can define your sandbox. So you could see here. So look at the setup for the sandbox, the setup function, and then look at the seed files, the file default files, and then look at your networking. So allowed host. So this is how you defined your sandbox. And then this is also kind of like your seed files that will be in the sandbox by default. So when the setup runs. So of course, network matters. So within your sandbox, as you're defining your sandbox, you could also have like your allow list. So for example, if you are doing npm install and pip install, allow host list is actually important. Maybe you don't want to allow like every other thing, but you just want to allow some packages to be able to install. This network option will be able to help you configure that. So for the sandbox lifecycle, so you could see that when the setup runs, the workspace is populated. So each time the setup runs again, we have a fresh workspace. So that's it. So now we're going to be talking about sub agents. So if you look at this folder from our project, so this is, if you look at the folder structure, so we have channels here, we have skills, we have tools, and we could also add sandbox here. So a new folder here called sub agent, sorry. So same with sandbox, we could add a sandbox, we could add sub agents. So let's talk about sandboxes, sub agents, sorry. So for sub agent, when you want to split work between, so you want your agent to be able to call other agents. So this is how you declare it. Declare it. So you write the sub agents and their ID, and then your agent is going to like use them when it's doing some job that require that particular agent. So let's go the built-in agent tool. So let's look at the built-in agent tool. So the built-in agent tool enables Eve to choose a particular agent that is required for a task. By default, every if agent has an agent tool. The model calls it to delegate a subtask to a copy of itself. So this is how it does it. So it delegates a subtask to a copy of itself if it want to kind of like um, run. So, but What copy of itself means same instruction, same tool, shares parent sandbox, fresh conversation history, fresh state, inherit auth and connection. So this is what it means by having a copy of itself. So in parallel, you could see what is our copy one, parallel fan out, copy one, copy two, and copy three. They are running in parallel. When to use the agent tool. So independent substance that can run in parallel. I need another perspective. Delegate to think about another approach. Split a big task into smaller focus pieces. This is when the agent tool is being used. So you can override the agent tool by building and routing to whatever agent you want by this special tool called agent.tx. So you see here, you could also kind of like declare your own sub agent. So see here, we have a sub agent called researcher. It also has its own tools, sandboxes, and sub agents. All these are optional, but you could just define like agent.ts and instruction.md, and that will be okay. So here we talk about the isolation bag, what children inherit, what is fresh. So let's look at what happens. So for instruction, inherit building copy will inherit parents. Declared agent will own its own instruction.md. For tools, built-in agents will inherit parents. This one will have its own set of tools. For sandbox, it will be shared with parents. It will have its own sandbox by default. History, it will be fresh. No parent history. Both will be fresh. State, fresh. Auth and connection, inherit. Also, this one will inherit same user because of course. So this table tells you exactly what happens behind the scene. So this is talking about like some delegation patterns, routing parallelisms, and special hands-off and resolve meshing. So parent process this 10 file. For each file in files, all the agents runs in parallel. Parents will now collect the result and summarize. So this is parallel fan out for the built-in agent. Two is specialist handoff. Fix the bug in order. Parents sees the task in coding related, delegates it to the agent that does call coder. So you see it's been dedicated to coder. So this is called specialist handoff. And then this is called parallel fan out. So you have research then act. This is a React agent. So delegate to researcher, investigate how to add feature S. Researcher return feature, delegate to coder, implement feature, delegate to reviewer. So you see, research, then act. So this is this approach. So these are some of the approach that you could use. So task mode and output schema. So when a subagent runs in task mode, it runs to completion and return a structured result rather than carrying on conversation. Task mode is triggered by providing the output schema, setting the output schema on the subagent, and being invoked as a scheduled task. So you could see the output schema on the agent tool call. So on the agent tool, the agent sends a message with an output schema and what will be required. And then this is fired to completion. So you see the output schema on declared sub agent. So by declaring this output schema and specifying it on the agent tool, so the child runs to complete and return the type object based on what is being defined here. And also in the sub-agent declaration, you also see the output schema being defined here. So here is why structure return matter for delegation. The parents reason over type data. So in a clean composability, parents code can branch on the result. Validation, if the schema fail, you catch it. So this is one of the reasons why. So stable contract, children become reliable building blocks. So because they actually know what to return back to the user. So we're going to be looking at schedule. So let's look at what schedule is. So schedule starts an agent on its own clock instead of waiting for an inbound message. So it just starts an agent using its own clock. So that's what a schedule is. So you could see here, so we could create schedules under schedules, biling, sweep.tl, daily digest.md. So, and the schedule, you could set them as cron jobs. So let's see how the markdowns of schedules looks like. So this is how a schedule looks like. So within that schedules a subfolder with the name of the schedule, this is what you create. You see, Eve runs the agent on a prompt and throws away the output. The agent can still call tools, write to backend, lock along the way. This is a task mode. The section runs to completion of phase and cannot pack to wait for a person or auth sign in. So this is how this mode is supposed to be. So that's what fire and forget means. So you fire, you wait until everything completes. So you see here almost the same thing. Clean up, weekly cleanup. So these are all how you could set up schedules. So the schedule also has an API. I think most of the stuffs you could do them using markdown mode, but if you want structure, you could also want to use the APIs. For schedule that need branching logic, channel hands-off, or per run configuration, use define schedule with a run handler. So you could see here, we have the run handler here, and you could see what is actually happening here. So you have receive, wait until app auth. A lot of things are happening here. So it's really more granular than the other one. Just like I said earlier, I'm going to be sharing this documentation with you for you to kind of like, so this actually shows you how to write this cron. So the first one is minute, hour, day of month, day of week. So you'll be able to compass this prompt. The last thing we're going to be covering is dispatch and def. So this is just for me to remind you that so schedules don't trigger while you are doing development. So, and that's expected. You can't be developing and be expecting your schedules to be triggering. So the way you test your schedule is using dispatch. So you do dispatch, for example, daily digest in the TUI, and that's how you get it done. So in the next couple of videos I'm going to be doing, I'm just going to make sure that I try to build like very production level stuffs using Eve, like agents that actually get the work done. And one of the things I've discovered is that I could, for example, move some of my agents. Sorry. So this is actually our agent interface. I want to So let's refresh this page. So this is actually my Gwenpa installation. So here, so what I could do is that to move all these my agents. So let's say these are all local agents. So if I want to take any of this agent to production, like this full stack engineer or whatever, I could move this agent. I could take, like, for example, let's look at this next builder. It has some set of files. So I could move most of these files into my instructions. I could migrate my tools, like tools that are similar to these tools, to the tools folder, write them all in TypeScript. I could add some specific skills in my skill folder, the same set of skills that I'm using. And then I could deploy my agent to production and put authentication. This is exactly what you get when you use Eve. So this is what you get when you use Eve. So as you could see, this is the first deployment I did that failed. So this is the current one. So we could visit it here and look at our agent. So we could chat with it. The name of the agent is written here. And then you could have an agent that could be deployed, could have authentication like Clark on top of it. And then you could get people actually use your agent.